All right, so for the past few days, we've found limits using tables. So seeing what happens if the numbers are converging to one number. We've also looked at graphs to see what a number is approaching. And today we're going to find limits using algebra. So this section is called Finding Limits Algebraically. Okay, finding limits algebraically. Okay, and I did show you there are some limit laws that you can use. They're just not particularly useful because we're going to use other algebraic strategies. So they are in your textbook. And then when you use the limit laws, you kind of write it out like a proof, like you do it step by step. And so when we do this with algebra, we're going to be writing the steps. We just aren't going to be writing the reasons with those. So we're going to find exact limits using algebra. And if we can, we're going to use direct substitution. Okay, direct substitution is the simplest way to find a limit. It's what you're going to want to check first. So you can use direct substitution if whatever the limit is going to is in the domain of the function. So what this is saying is this is the limit as x goes to a. I feel like that's kind of hard to see. So we're going to just write that out. If you have the limit as x goes to a, okay, and then a is in the domain of f, then you are going to plug in a for the variable x. All right, so in order to see if we can use direct substitution, we do have to check the domain. So this says evaluate the limit if it exists. So limit as x goes to 2, you have x squared plus 6x over x to the 4th plus 3. So when you're checking the domain, if it's a fraction, what can't you have in the domain of a fraction? Yeah, so the denominator can't be 0. So if you have a fraction, we know that the denominator can't equal 0 for the domain. So we set it equal to 0 and we solve. Okay, so if we have x to the 4th plus 3 equals 0, then we'd have x to the 4th equals negative 3. Okay, and then we'd have to take the 4th root of both sides. Okay, but you can't take the even root of a negative. Okay, which means there's no solution here. If there's no solution for the domain, that means there's no restrictions on the domain. Okay, so no restrictions is the same thing as all real numbers, right? You can plug in anything and you can get a value out. So if the domain is all real numbers, then you can use direct substitution. Okay, and all we are doing for this example is we are evaluating the limit if it exists. Okay, so we're going to use direct substitution. Since, and the main key here is this x goes to 2, okay? So you're using the direct substitution since 2 is in the domain of the function. And remember, all that means is that you can plug in 2 and you can get a valid answer. Okay, so if you can plug in 2 and you can get a valid answer, that's what you're going to do. Okay, so you're going to substitute x equals 2. Okay, and when you do that, you can just substitute it in here. So it's 2 squared plus 6 times 2 divided by 2 to the 4th plus 3. Okay, so go ahead and find that. Okay, so 2 squared is 4, 4 plus 12, 16, 2 to the 4th, 16, 16 plus 3. Okay, so this is your limit. This is your solution. Okay, that is something that you can verify with a graph or a table, but you don't have to. Okay, so if you can plug in 2 and it's in the domain of the function, you use direct substitution. Okay, so that is actually going to be rare. So evaluating those limits with direct substitution is pretty simple, but generally, if you can find it that way, it's not worth calculating. So a lot of limits cannot be calculated finding the direct substitution, or they cannot be found using the direct substitution. And most of the cases where the limits are useful, it's going to require us to work harder to find them. So the next examples we're going to do, we're going to use algebra to find limits. Okay, this passage was taken from your book, which was written by Stewart on page 582. So a little annotation for you there. Okay, so for this one, we can't use direct substitution. Okay, let's think about why that is. So this is the limit as x goes to 4. Why can't I use direct substitution here? What would happen if I plugged in 4? Yep, it would make the denominator 0. Okay, so 4 is not in the domain. Okay, you can say it would make the denominator equal 0. It would also be a special value that we talked about on Friday. Remember, if you plug in 4 here, you're going to get 0 over 0. Do you guys remember what we call that? Yeah, you'd get the indeterminate value. Okay, so we can't just plug this in. We would end up with 0 over 0. The denominator would be 0. Okay, 4 is not in the domain. Okay, so I told you guys at the beginning, I took off the limit laws. I used to do them, and then I just don't see a lot of value in it. So that's why I have this. Can we apply the limit of a quotient law? So the quotient law just says, oh, can you just find the limit of the top and then do the limit of the bottom and then find it? And you wouldn't be able to do that because in that quotient law, they tell you that the denominator can't be 0. So for this, we're just going to write because the denominator would equal 0. Okay, this isn't something that you need to worry about or something that you'll have to think about in terms of the quotient law, because it will relate back to this. Why can't we use direct substitution? So the denominator would be 0, so we know it's not in the domain. That's going to be the indeterminate value. So what should we do? What should we do here? We can factor, yes. I was telling one of my other classes, I wish I had confetti cannons. So when somebody said a right answer, wouldn't that be fun? Just they'd all fall down. We can factor. Okay, now when you are writing this out, you have to keep writing the limit first. Okay, and that can be easy to forget. So you guys remind me too if I forget. So the limit is x approaches 4 of x minus 4 over, and then we're going to factor this. So it's going to be x plus 4 times x minus 4. Okay, so you do have to keep writing this limit, okay? And then don't write in the cancellation. We just write this from step to step. It is very similar to how you write the reasons of a proof. Don't be scared because I know proof is a trigger word for many of us. Okay, you are just writing down, step by step, okay? So if you cancel out the x minus 4s, that leaves you with 1 over what? Yes, x plus 4. And then eventually you will get to a place where it is okay to use direct substitution. So now if I were to plug in 4 here, would I get a denominator of 0? Nope. Okay, so I can do direct substitution. I'm just gonna write that here. When you do direct substitution, that's when you drop the limit. Okay, so you do need to write down what you're plugging in. Direct substitution just means you are plugging this in for x. So I want you to show that first step, and then after you show the plug-in, you can use your mental math. Okay, and then your solution for that is 1/8. Again, that's something that you can verify with a table. It's just when you're using your table, you would end up seeing like it would get closer and closer to the 0.125. All right, so now we're gonna try a different strategy with part C. So you always want to look and see what the limit is approaching. So x is approaching here. X was approaching 4 for B, but in part C, it says h is approaching 0. Okay, so I want you to think about a strategy we can do. And I also just want to write a little note here. So in terms of your notation, you are going to write the limit until you do direct substitution. Okay, so when you're writing this on your own, you write the limit as x goes to a value until you use direct substitution. Okay, then you just plug in that value for a, which is what we did here. So once you plug in that value for 4, you don't have to keep writing that. Okay? Okay, so in this one, why can't you substitute? What happens? You plug in 0, you'd have the denominator is equal to 0 because of that value of h. And is it the indeterminate value again? Okay, so if you are getting the indeterminate value or if you're getting the denominator is equal to 0, then you can't do direct substitution. But if you don't, then you can use it, okay? So sometimes you will be able to use direct substitution, other times you won't. All right, so what can we do to simplify this one? So in this one we factored. We're going to do another F word in this one. Not that one. FOIL! We got it! Okay, so we're going to expand with FOIL. All right, so then when we do that, we're going to keep this limit here. So keep that notation. It's the limit as h goes to 0. I'm going to write out the 4 plus h times the 4 plus h. If you want to just jump right in and do the foiling, you can. It's just, I noticed that sometimes people forget when you foil, you don't square both of them. You do have to make sure you do the first times the first. So you have 16, the inner and the outer, which is 8h plus h squared minus 16 over h. And then I want you to see if you can do the next step. All right, so when we clean that up, what was left on top? Am I going too fast? Or are we ready? Yep, h squared plus 8h over h. Okay, and then here you can either do two things. You can divide both of these by h, or you can factor out an h. And if you factor it out, those divide. So if you factor out the h, you can divide. Okay, and I can't do direct substitution yet because that would still give me 0. Here I can do direct substitution. So once I do direct substitution, that's when I can drop the limit. Okay, so once you can do direct substitution, okay, that's when you stop writing the limit. And again, I want you to write this first step. Okay, so I want you to write the substitution. So I want to see where the 0 is going. Okay? All right, any questions on the first page? All right, then in part D, you have the limit as x goes to 1, root x minus 1 over x minus 1. Okay, and I really kind of told you what we were going to do. Why do we need to rationalize? Okay, we're rationalizing because you can't use direct substitution. And you guys know why now, right? Why can't we use direct substitution? Yep, the denominator equals 0, and you'd get 0 over 0. Okay, so there's that repetition so that you guys understand why we can't use direct substitution. But you always want to check it first, because if you can, it's pretty simple. You just plug it in. So way back in the fall, one of the first things that we did, I believe we did this in chapter 2, is we rationalized the numerator. Okay, and you're like, what? Why are we doing that? We've always been rationalizing the denominator. And I said, there will come a time where this will be useful when we do limits, and that time is now. So we are going to rationalize the numerator. Okay, which means you have to multiply by the conjugate of the numerator. Okay, let's see if you guys can figure out what that is. So you're multiplying by the conjugate of the numerator. And that's so you don't have a square root in the numerator any longer. All right, Kinley, you got this? Okay, so can you tell me what part of it would be? Mira, what are you thinking? Yeah, yeah. Do you know what do you think you're going to multiply by? Yeah, square root of x plus 1. Yep, over itself. So if it's a minus, right, we're going to do the plus version, and it'll always be the same thing except instead of the sign, you do the opposite sign. Okay, so now we're going to FOIL. Okay, and then for this step, you're writing the multiplying, so you don't have to write the limit with that, but now that we're FOILing, we do have to write the limit as x approaches 1. All right, so root x times root x is going to be x. The inside and outside are going to cancel. -1 and 1 minus 1. Now, in the denominator, do not FOIL these out. I want you to keep it like this for now. So I want you to write that as multiplication. So you have x minus 1 times root x plus 1. Okay, is there something that you see that we can do in our next step? Yeah, this is going to be the same thing. So whenever you have a fraction, remember, there are these understood parentheses in the numerator saying you have to do the numerator before you go to the denominator. Okay, so then our next step, we're going to write out what it would be when they divide. Because this divided by this is going to be 1, so it's 1 over the square root of x plus 1. Okay, and we couldn't do direct substitution here because we'd end up getting 0 here. Okay, but can I plug in 1 here and not get 0? Can I do my direct substitution now? Yeah, so when you do it, you can drop that limit. So it's 1 divided by, and like I said, for the first step, I just want to see where you're plugging it in. Okay, we're doing the direct substitution here. And then from there, you can do your mental math, okay? Because the square root of 1 is 1. 1 plus 1 is 2. Okay, so your solution is going to be 1/2. All right, can you guys think of questions that you have? Yet? All right, then the last type of limit we're going to look at are limits that have the absolute value. So what we have to remember with the absolute value, we actually have a piecewise function situation here. So in a piecewise function with the absolute value of, this is t, we have two cases, right? Whatever's inside the absolute value, it can be negative or it can be positive. So it can be negative t or it can be positive t. Okay, it's negative if the value is less than 0. It's positive if it is greater than or equal to 0. So yesterday when we were looking at the limits and we were talking about the two-sided limits versus the one-sided limit, okay, if it was negative, it approaches 0 from the left. Okay, because if you're getting closer and closer to 0 from the left side, it's going to be those negative values. And then if it's positive, remember we would say it was 0 from the right. Okay, so what we have to do here is we just have to evaluate each side. Okay, and this is when you have the absolute value. And then as we recall from yesterday, if the limits on both sides are the same, that just means that the limit is equal to that value. Right? Yesterday we saw if they were 4 on both sides, then the limit was equal to 4. But if they weren't the same, then what do we know about the limit? Does not exist. So if they're not the same on both sides, then the limit does not exist. Okay, so anytime you have the absolute value, you're just going to have to find what happens from the left and from the right. Okay, so for the negative, it's going to be from the left. For the positive, it will be from the right. Okay, so the way that you would write that out is we're going to do the limit as t approaches 0 from the left of the absolute value. Okay, so the limit from the left, okay, from this negative value here is just negative t. So from the left, it's your negative values. And then with this, you can use direct substitution. You can plug in 0 because you're not going to get an indeterminate value. If you plug in 0, what do you get? 0. So you can write negative 0 equals 0, but don't write negative 0 in your final answer because you won't have negative 0 or positive 0. Okay, and then we're going to do the same thing on the other side. So we're going to find what happens as we approach 0 from the right side of the absolute value. So from the right side, okay, that's just the same thing as t. That's the positive value. Again, you can do your direct substitution. And get 0. So if it's 0 on both sides, then we say the limit as t goes to 0 of the absolute value equals 0. Okay, so that is your final answer. Okay, so some of you might be thinking, well, why did we go through all that just to get 0? So it is not always going to be the same on both sides, okay, which is why we have to test it. I wanted to start off with one that was pretty straightforward. So when you have the absolute value of t, okay, you always have the opposite of what's inside the absolute value, okay, and the same as what's inside the absolute value. And you evaluate from each side. So in the next one, in F, we're going to look at one that's a little more complex. So this is the limit as z goes to 0. This should be a lowercase z. It looks capital to me here. But just so you know, those are the same variable. So because of the absolute value, we're going to find this from the left and we're going to find it from the right, okay? So first we're going to go from the left. So from the left, we're going to do the limit as z approaches, and this time it's z goes to 0, and then you have the negative for the left. Okay, now for this one, it was just t, so it was just negative t. Here we have this whole thing. So the only part that's in the absolute value is the top, so the bottom stays the same. And then you just do the opposite of the top. So you can put the negative on the outside. If you want to distribute it, you could do that. But from the left side, that means you're applying the negative to the absolute value. You guys with me with that? So whatever's in the absolute value, that's what gets the negative. Okay, and then can we do direct substitution? Yes, so that's what we're going to do. Okay, so when you can do it, direct sub, you're just going to plug in z is 0. All right, so I want you to do that, and I want you to find what the final answer is, okay? And if you're feeling like you want to set up the one from the right, you can. If you want to wait for me, you can. All right, so then when we did the direct substitution, we have the negative 2 plus 0 over 2 plus 0. So negative 2 over 2, which was negative 1. Okay, all right, now let's see what happens on the right side. So from the right, the limit as z approaches 0. Okay, all we do, just like we did here, we had the opposite, we had the same. Okay, so here we did the opposite. Now we're going to have the same thing on the top. And the bottom has to stay the same because it's not even in the absolute value. Okay? And then you can just do your direct substitution. So if you do the direct substitution and you plug in 0, what did you guys get at the end? 1. So the direct substitution, you have 2 plus 0 over 2 plus 0, which is 2 over 2, which is going to be 1. And what do we know about our limit? Does not exist. So if these are not the same, okay, then your solution is limit does not exist. Okay, if they are the same, it would be that number. Okay, and then just remember to receive the full credit, you just have to show your work and find those limits using algebra. Okay, if you want to check your work with a graph, you are welcome to do that. And then I'm going to give you the rest of the time to work on this.